without having to deal with desk. So yeah, in this next example, I'm not trying to explain exactly how you would use HV-plot, just giving some motivating demonstrations of using it. So you supply a whole bunch of keyword arguments into it, and that's going to control how the plots will behave. So, for example, this rasterize in there is using data shader underneath to sort of adaptively generate these plots without plotting everything on top of each other, because this is a scatter plot of how many? Yeah, 500,000 data points. So if you were to plot that directly, you would have a problem. But if you see, you can zoom in there, you can see the individual data points that are contributing into it. And as you zoom out, data shader sort of automatically deals with them. There's some hidden options in here. I think it's using the mean of the data. So say for a particular pixel, it looks at all the individual data points inside there and evaluates a mean of them to show the appropriately colored pixel for that point. And you can change which function it will use. So that's called the aggregator. So you can aggregate it in different ways. And this is just using the mean. So you may want to change which aggregator is being used. So this is the same as before, but we're just plotting the different parameter there. So this is the perturbation. So this the data model residuals, and you see looks quite different, right? And all this speckly stuff up around the poles is to do with the auroral oval. So this is electric currents, field aligned currents, no auroral electrojets. And you can see how they affect the different vector components differently. So this next plot is the same data as above, but instead of plotting against longitude and latitude, we're plotting against MLT and quasi-dipole latitude. So now you see these consistent patterns in here. So in the center here, this is 12 noon. So this is the day side of the ionosphere. So you see this, you see these two cells from the SQ current system, and then over the poles you have the patterns from the polar current systems. So you can see how you go from just this simple access to this data set, and you can immediately create these kind of high-level visualizations that have some physical insight to it, and you could then pipe these into some other kind of statistical analysis, and it's kind of easier to reproduce because there's fewer lines of code to get here. So yeah, this next tool I want to show is HV-Plot Explorer. So you could see coming up with these kind of recipes kind of hard because you need to have some experience with the library to know what you would want to do. So Explorer is a way to try and overcome that issue. So at the moment, it doesn't work with X-array data sets, but it does work with data frames. So here I've just converted it to a data frame, and we can visualize that straight away in this automatic dashboard, really. So you can click around and change what you want to plot against what. So if I say plot against latitude there, now we can see a different plot generated on the fly. And if you want to play around with this, there's a couple of examples you could do this. I would say it's when you're generating these kind of plots, if you're putting a large amount of data into it, it is very easy to accidentally put something in that will overwhelm your computer using too much memory. So you've got to be a bit careful with that. The other nice thing about using the Explorer here is it has this plot code method that gives you then the code that you would need to reproduce this figure. There's a whole bunch of things that you can do in there, so you can just type in what kind of things you want to put on the labels and so on, and just generate the code to reproduce it directly afterwards. Yeah. So then, how we don't have time, another 5 minutes or so. So Yeah, I actually just had a look at this last week, sort of for fun to see how well it would work. So PyVista is one of several 3D visualization tools in Python. So just show how that works actually. So yeah, the first thing is data shader again, actually. So this is just simplifying the data that we're working with. So it's selecting out a particular component of the data. And again, because it's using X-ray, it's pointing to the original data object, and because we loaded it using Dask underneath, that was a bit transparent, but it did happen. And you can see that it's not actually loaded in the data at this point. It's still out of memory until it actually needs it. So data shader here. So this is an example of using data shader more manually, using its direct calls rather than the kind of magic that happens underneath in HV plots. Yeah, you probably read that already, but I used ChatGPT to help me write some of this, and it worked surprisingly well. Just had to tweak it a bit afterwards. Yeah, so this is I've kind of glossed over it a bit before, but there's that aggregator, and I told it to evaluate the mean of this particular parameter, and then out from that, then it can generate this image. It's quite nice to be able to look at kind of the full data set, as it were, in aggregate rather than the individual components of that at a time. And you could imagine creating some more interactive dashboard around these tools, where you can pick and choose what to plot and select the data going into this. So say if you selected geomagnetically quiet data, this would look quite a bit different actually. So yeah, this next bit is just some stuff for mapping the data onto a sphere. So it's just taking this picture and mapping it onto a sphere using PyVista. So just click that here. Don't know how well this is coming over the video link, but this is quite nice to play around with. You can get some intuition about the data, and by kind of delivering it through this data cube approach, that really helps to make this kind of thing reproducible and kind of hackable in relatively few lines of code. So I think I'm going to leave it there. Does anyone have any kind of questions or comments about this?
Yeah, hi, Ashley. This is John Vandergriff. I might have missed this at the beginning, but getting the data into the right structured so that it can participate in this kind of analysis, what does it take to do that?
Well, so I use Virez for this. So it's the way that I did that is something I want to revisit and do better. But it's essentially just making repeated calls to Virez, or you could do the same with Happy, of course, and taking out, say, a month of data at a time, and then concatenating them into one time series and storing that. But it's something I need to explore a bit more about the data formats and so on. Like I think I used the NetCDF in this case, but I think it should be transferred to ZAR, and also explore the way that the chunking works there, because that's quite the way that you chunk the data set into parts that makes it very sensitive for different kinds of analysis. So depending on what kind of computation you do, it'll be less or more performant, and that's really critical, getting that chunking reasonable. So these are parameters that can all come from Varez in one request. So it's kind of quite simple to build something like this, but then actually leaving it to run for a while to aggregate that over several years of data, that takes a bit longer. But the main point really is to do some of that processing up front. So
that's what I was asking about.
This kind of thing is not too heavy. It just takes some hours, and then once you've got that, then it's something that you can deliver to other people in some way.
Right. So you went through and pulled out the parameters that you want, obviously, and then stuff. Was it one huge netcdf file with all of this, or?
Yeah, this is. Yeah. It's only one gigabyte, but
okay.
Yeah, but I mean, in principle, it can be larger. Yeah. So I mean, it does that because of the way Xfree and Dask works and so on. Like it could be one large file or lots of consecutive files, and you can just point to them using Xarray.
Okay.
But that's the thing that's kind of difficult for me to explore, because I don't really know what I'm doing too much. That I think there's some kind of chunking that needs to be done, and whether that means it's something that needs to be explored a bit more. But the other thing is that these are sort of combined from different data sets in a way, and these are evaluated on the fly. So this data set I've shown here is actually a subset of a larger one that I used in a research project. So it's just something that I built in the process of another research project when I want to look at all this data at once. So I built this thing, and that included also data from SolarWind, from Omni, and so on. So the idea is to combine maybe different data sets together to provide this analysis-ready data that's not the original data. Some of it's the original data, some of it's model data, some of it's auxiliary parameters, or even other data sets. Some of these should be combined into one data cube like this, and some of them might be different data cubes that you would kind of plug together. So I could imagine having, you could very easily have another similar thing like this with SolarWind conditions. And you could access them both in the same mechanism, which would be very helpful.
All right, just double checking. Any further questions? Great. Thanks, Ashley.
Right, thanks.
So next up, I believe it'll be Sandy presenting on Helio Cloud, a nice demo, basics and recent updates and everything in between.
I believe that too, and belief is what determines everything.
Take it away.
So I'm really psyched to actually be following Ashley, because my talk is a little more upstream before you get to the rich science stuff. It's actually tackling one of the questions from the poll of how do you get big data off of S3 quickly and cheaply. So I will be presenting Helio Cloud, which is an AWS-based environment for analyzing Helio and solar data. But the root of the tutorial is how you can rip through 1 year of SDO data in under 30 minutes, which is 1.8 terabytes of data processed in a very straightforward way. The Helio Cloud team is led by Brian Thomas from the NASA side, and I guess me now from the APL side, with a lot of people working on it to build infrastructure. And in both the chat, the Slack, and you can see on the bottom of the slide, there's a GitHub repository with Python code that hopefully you all can be quickly downloading to follow along for the at home or in audience edition. One key thing about HelioCloud is like Pangeo and other setups. It's an infrastructure or platform. NASA via SMC runs a HelioCloud instance that you can get an account on and be doing work on, but any institution can build up this infrastructure. And we're aiming for a private alpha release at the end of June and a full release in December. So the idea of HelioCloud is distributed researchers able to do all the stuff that we want to do. Discover data, share it, publish, collaborate, work with very large collections of data and other research artifacts. So for this talk, I'll give a very brief interview on HelioCloud for those that aren't aware of it with 3 slides, talk about some of the tools, and then go right into the example of accessing 1.8 terabytes of data on AWS S3 via Python using Dask to throw lots of CPUs at it in order to get a simple result. And then we'll close out with what we have learned from this today. So again, HelioCloud is a AWS cloud computing environment that also has a analysis cache of large data sets, such as all of See the Web, all of MMS, all of large parts of SDO, with GUIs on top to make it so you don't have to understand which of Amazon's 68 different services apply to something. So we're going for easy collaboration via notebooks and that classic science analysis via GUI that people talk about. Direct access to all the AWS powers and control on the costing so that you don't accidentally overspend. And of course, the big cheap storage that cloud provides. The obligatory architecture diagram here shows the shared open architecture, all of which is being released as open source and modifiable. And a given HelioCloud instance, whether it's the one at Goddard or the one at APL, or maybe LASP will spin one up, etc., contains the underlying stack that things run on, a user dashboard for spinning up your own VMs and sort of doing your classic thin client login via SSH and do lots of stuff, a Dask Hub environment with notebook support, and the storage as well. So looking at the capabilities that I just enumerated, the Dask Hub has the classic ability to do notebooks or terminals within your browser for doing your coding, your development, and especially your sharing. And then your code can burst into the cloud. You can throw a lot of machines briefly at a large task to make it go quickly. And that will actually be something we show in this tutorial, with support for Python, IDL, Fortran, MATLAB, and other languages coming in. There's also a dashboard where you can spin up an AWS VM. You can now SSH into. It can have a static IP address, so that you can put a server or permanent or semi-permanent model generator or other tool upon it. And it does allow, even from the NASA instance, the non-NASA host names. And then finally, S3 storage is the big cheap disks that AWS provides. The Goddard HelioCloud has access via NASA TOPS to, I think it's 2 petabytes potentially of free storage for significant data sets of note. And then all of this is available for Goddard researchers and their collaborators. So if you have a something that connects in with NASA, talk to Goddard, talk to Brian specifically, and they have very fast onboarding for projects. So, the key is it's a roll-up of known solutions with a scientist-friendly reskin. So one of the tools mentioned is the user dashboard. This is what you would see for any, VM provider, likely at your institution. It's a very simple user portal that comes up. It tells you how much you've spent and how much your recent spending is. And then it lets you launch a VM instance with one button or restart a previously stopped instance. And it provides data as well. In addition, it also generates SSH keys for accessing your VM and accessing data sets that might be locked down. One area that we're really working into is being able to have data sets that are public, private, or shareable, that you can share within a team, but not make globally public, so that you have some granularity in the control. And the notebook environment, which should look very familiar for people that have worked with notebooks. Again, the idea of notebooks generally is you have code plus descriptive text that lets you walk through things, and it all just works. The notebook runs on top of a container that has all of the PyHC packages built in, so that you don't have to be worrying too much about imports and other things. And then the notebooks within Dask Hub have the ability to burst into the cloud and throw lots of CPUs briefly at your code. So the idea of the notebook is you can ship the notebook around. I provide a GitHub link to the one for this demo, lets you do easy collaboration and sharing of data, code, and results. And all these are supported within Helio Cloud. So in order to get to the data, we'll be working with SDO. We've defined a shared cloud registry that's still looking for a cool name, because shared cloud registry seems very generic. But the idea of this is, if you have a large data set, say 300 terabytes of SDO data in the cloud, it's very inefficient to find it just doing an ls-r or similar, and it's also very costly. So this is a bit of infrastructure where you have JSON objects and CSV files of the contents that sit alongside the data. And then we also have an API for rapidly accessing them. These indexes are not a database. They are not a fully searchable item. They are a layer upon which searchability and findability can be built. They are simply a CSV file of time, the S3 location or other cloud location, and the file size, plus any optional metadata that you want. The idea here is it's a very low-cost static solution that conveys with the data set, that is easily accessed by other programs, that search layers and other things will eventually be built upon. So if you have a Helio Cloud instance, you tell the central registry what buckets you wish to make public, and they become available to all Helio Clouds. Within your S3 bucket, you then have a JSON file that lists which data sets in there you wish to make public and where they are. And then for each data set, you have CSV files that list the holdings, so people don't have to do an LS. And we'll walk through how that works at the user end a bit in this tutorial. But if anyone is like, wow, I have a big data set and I'd like to make it available to Helio Cloud, you can talk to me about how to do it. And you can talk to Rebecca, who's been testing it out with her massive multiplayer executable paper, to find out how easy or difficult she found it to implement. So for this tutorial, we'll be going into using the Helio Cloud S3 storage of SDO, plus that Dask burst capability to look at SDO data. And there's sort of a recap of the elements that we have.
Sandy?
Yes?
There was a quick question in the chat from Sean about the
All
PyHC
the
packages.
yes,
Yeah.
all with an asterisk. So I'm not actually up to date on the container. Brian would probably be able to answer that. We definitely have the core packages, but we do not have everything in PyHC, partially because of the incompatibility and partially because of the size that packages may take up. So yeah, we're kind of being in an early release. We're kind of at we have the core packages and what people are using. And if you want something added to us, let us know so that we can put it in. And then once we get that unconference or future work that makes the perfect container that has all of PyHC with its, versioning solved, then we can talk about making that available.
Can I make a quick comment too?
Yep.
There may be in the future options for different flavors of containers. If you start adding things like, oh, I want to be able to do machine learning with SciPy, that adds a lot of volume. So depending on what you want to do, you make a selection and the right container will be associated with your instances. That way you're not going to use that extra whatever gigabytes of all the stuff that comes in with SciPy. You don't have to.
Yeah. So with Amazon, you pay for storage. So if you are using, 4 gigabytes of fast disk in order to have packages that you don't need, that can accumulate over months. So there's always a tension between having a container size that is small, nimble, comes up to speed quickly, and having a complete container. And I think that'll be a discussion that goes on for the next year rather than being easily resolved.
And really large containers don't load quickly, or they even break when you try to spin up a VM with it if it's too big.
Yeah, there's a whole separate thing of tuning also. How big a VM do you want in terms of CPU and memory versus what the cost profile is? I'm actually not going to be going into costing with this one intentionally, but we can always put that in at Dash, because I do think for the Dash conference in October, for those that don't know, there'll be a data analysis and software systems conference in October. It's October, right, John? Let's have a brief aphasic moment.
9, 10, and 11.
Yeah, October 9, 10, and 11, followed by the IDEA workshop for people to talk about software and similar at APL. So, this is definitely ongoing, especially costing. Right now, I'm sort of talking about infrastructure and implementation levels. All right, why SDO? SDO is big. So there's like 300 terabytes of it. And for this example, it's going through 1 year of SDO, 94 angstrom EUV data from AIA code. So that's 130,000 files, and each one's 14 megabytes. So it's 1.8 terabytes of data, which I am calling too big to put on your local laptop easily. The science part of this is very minimal. I'm just calculating a simple irradiance change over time to show feasibility of it. If you did this serially on your laptop, I profiled it, it would take 27 hours. On Helio Cloud, it takes 25 minutes to go through this. So that's 88 files per second being processed, or 1 gigabyte per second, which, looking things up, is twice the speed of just reading data off a SATA SSD, do the parallelism. So it's actually just doing the analysis is 2 times faster than it would take just to copy the files off a local disk, and 8 times faster than just copying it off internet. And you're not using any local disk with this, because the key of using a cloud system like AWS is you move the compute to where the data is stored, and you simply take your results. So if you have the code up, if you go to the GitHub, there's a mini Python routine that runs serially that anyone can do. And this code is in there. And then there's the full notebook for those of you that A, have a notebook environment and you want to run it locally, or B, are on a cloud environment and you want to run it from the cloud. It should work on any cloud. And it does have a copy of the file registry code, scregistry pre-release.py. That's the only additional import needed. And then you will need the Boto 3 package for the Amazon S3 read. So if you're doing this locally and you haven't used AWS, pip install Boto 3. Dask will be needed if you're going to be doing Dask work. The others are standard packages, plus, of course, AstroPy, because the SDO data is in FITS format. If you are not using Dask, you can ignore the Dask ones and not do that part of the tutorial when you run through it. All right, I mentioned that there's a file registry with a list of all catalogs. This is sort of a digression. If you're like, hey, what data is available to all the Helio clouds out there? There's a central registry, which will eventually be on a GitHub site. But for now, I have as at a personal site just for testing, because this is all secret pre-release stuff that no one else has used yet. Ooh, even I just did most of this last week. So this is very new, fresh, how to do stuff. You're on the inside track. So you can list using the API, the SC registry, you can list what catalogs are available. If you look at some of the output there, you can see that there's a S3 Helio Public and an S3 Gov NASA HDRL Data 1. So far, those are the only 2 that are registered and known to the world. Those are two S3 buckets that have data sets. So this is a layer that allows Helio clouds to say, hey, I'm making data available. Now let's get into the actual data. So here we're going to get the file registry from the NASA TOPS bucket, Gov NASA HTRL Data 1, where SDO and a couple other data sets exist. Well, actually, no, it looks to be just SDO is registered here. And getting a listing of the data sets, you can see you have the EUV images from AIA in the different wavelength bands, plus some HMI data, usual kinds of things that you want. Cell 4 shows the very straightforward way you would expect. You give a data ID and you get from the file registry its metadata. In this case, it has things like who made the data, what's their description, how do you want to cite it, and the most important, start date and stop date that the data runs from, which in this case, we're going to pull and we find out that we have data going from 2010 to 2022. So this is what we'll be playing with, this AIA 0094 data set. Now to get the list of all the SDO files for that entire time span, it's a simple API call, request file registry for that ID with that start and stop date. And that gets returned as a pandas data frame. So you can see the pandas data frame there. What's it got? It has the start date. It has the key, aka the URI or the pointer to the actual file and the file size for each of the files needed. In this case, I'm grabbing 1 year's worth of files, so it's just under 130,000 files. If you grab the full 1 million files for all of the 94 angstrom band, that takes less than 4 seconds to get that file registry. So this is a very quick way to quickly get the pointers to the data. At this point, you can do whatever coding you want because you have a list of all the files. You can walk through each key and you can fetch them. And so that next part we're going to do is we're going to walk through and do something with the data. But the file registry, you could put in any Python code right now, and now you'd have access to all the 300 megabytes of SDO data in some way, shape, or form, because this will give you the pointers to it. All righty. This is, as far as all the files, this is the SDO. Man, people are definitely catching me on overuse of all. This is all the SDO files that were provided by SDO for the Helio Cloud Analysis cache. So it's 300 terabytes of SDO files. I actually do not know the criteria for what they provided in terms of in terms of that. So that would be an interesting question. Because yeah, looking here, it is definitely the 4-minute cadence. So if anyone that helped with shipping the data over wants to type in the chat how SDO decided on this subset, that would be useful. And if we want to get a higher subset, the nice thing about Helio Cloud as an analysis cache is if you want data for a project that's justifiable, it can be put into the 2 petabytes of available storage, and it will sit there for the duration of your project plus as long as people are using it. Very clear that the Helio Cloud storage is free, accessible within AWS or external, but it's an analysis cache. It's not replacing the archives. It's providing a cloud copy that people will use. And if people aren't using it, then there's no guarantee that will be there in the future. So we are going with data sets that people use as an analysis cache, but we also take requests. The requests have to be driven by science because the end is we want science papers. We want Helio Cloud to be a science paper generator. And so if you can give us a science reason to do so, you can get $2,000 free in AWS funding from Helio Cloud and be up and running on it. And then we can start requesting data sets for you. So here you can see the massive science being done here. So I made a routine called do science. Here I am just getting a mean from the data frame to get an irradiance for each data frame, so I can look at the data at the irradiance changes over 1 year. Clearly, there can be much more better science put in here, but this is showing how you can rip through all of the data and do a simple science thing. So we're not going deep into the science. We're showing that you can do it. It's up to the scientists to decide, is it something that you should do? There are handlers needed. There's a very simple thing that converts an S3 URL, that S3:// file name like descriptor, into what AWS expects of, here's the bucket and here's the key. Trivial. And then there's a process, a fits file from S3. This should be familiar to anyone that's tried to use S3. And if you haven't, you can just take this pretty much as is and modify that line where you're pulling the data, any data or header key fields that you need. In this case, it's pulling the date from the fits header, and then it's giving a value I'm calling irradiance from the do science function, which again could be returning anything, data, pandas array, whatever. And you can grab other fits keywords. Don't need to go deep into that. It takes a S3 fits file and it returns the stuff. Alrighty, if you are trying this on your laptop at home, not in the AWS cloud, you can do this with serial processing. It fetches, it takes around 1 second to get a single SDO file on AWS serially, and it takes about 2 seconds on my Mac, not being on AWS. So if you want to run through all 130K files at 2 seconds per to process them, more power to you. Literally, like you should be moving more CPUs to the data. Fetching via internet defeats the purpose of putting cloud data in. You should be going into the cloud to do your analysis and taking your level 2 or level 3 or distilled results or your data cube so that you can then apply Ashley's methods, etc. From it. So this is all raw data. But here you can see it's very simple. We go through 10 files, we get the results from processing it, and we get the mean value of the files that we can now plot. And it took 9.75 seconds for 10 files. Very nice and convenient there. So with everything that has been shown in this tutorial so far, you now actually can access S3 data. Dask. I'm a monkey at Dask. I follow the examples and I'm not really good on tuning, but setting up the Dask burst, this is from the Helio Cloud demos. You set a certain number of workers with memory and core. These are the machines that the VMs that will basically be quickly spun up, or the CPUs to throw at it. You start a gateway, you call up the cluster. I think I heard Julie. If it's a question, chat would probably be better. And now actual code, since I'm low on time. But actually I'm tracking. So you map it to
clarify, I didn't ask a question, Sandy.
Okay. I thought it might also be a time check. So to use Dask, this is really using Dask. You map it out to the cluster that you've built, and then you gather the results. Mapping it out takes about 6 seconds. Gathering the results took 25 minutes in that case. And then when you're done, you shut down the cluster. Now everything sits in your results. There's a cool tool for visualizing what Dask is doing in real time. Fascinating, looks like a very good cyberpunk movie. I have no idea what most of it is, but it shows the system chugging along. The main utility of having the visualizing tool is if you can see if you're stressing memory, CPU, or disk. In this case, it's all CPU because there's not heavy disk use. It's just bringing files in. And then 25 minutes later, results. 130K files, 1.8 terabytes in 25 minutes, plotting the irradiance changes over 1 year for AIA 0094. It actually took 10 minutes for the plotting function to generate this plot, which I find humorous, that it takes nearly on order the time that it takes to generate the result as it did for matplotlib to handle 130K points, but that's more of a trivial thing. End result. This is an easy model of code that you can use to start looking at the SDO data at 4-minute resolution that's available now to any researcher, either within the cloud, or if you need to access a subset of SDO, it's there as well. And you can use the code samples to do so. I'm actually running on the entire time span for this data, just to see how long that takes. We're at about 1 hour and it's still chugging through the data, so I don't have any time details on that. I should switch to Plotly, but this was me lazily going with what I know. This is all non-optimized code. The Dask work is not optimized. I tried a couple different parameters and it usually came out at 25 minutes, whether I used 5 times as many workers, more RAM, less RAM, etc. Optimizations will be probably something we present in the future, probably as opposed to PyHC. Hey, we finally have some data on optimizations. I will say the lack of optimization is, one, because I'm new to Dask, and two, that if someone like me can get this done in 2.5 days from scratch, then you all can do way better with the knowledge that you have, because I was new to Dask and developing the software along the way. So it's actually really easy to get going with accessing massive data on AWS S3. That would be my walk away from it. All righty, closing out with Helio Cloud. So there's 115 users in HSD's instance of Helio Cloud already. We have the core capabilities of Dask bursting, being able to access GPUs, which I haven't played with yet, being able to start and stop the AWS EC2 VMs, which is basically decide what size CPU and memory you want and get your VM allocated. The PyHC based container that does not contain all of PyHC, but is definitely a best of edition. The Helio ML involved. It's been stress tested with 800 simultaneous users in PyHC Summer School. And from the comments, I heard comments that PyHC Summer School environment was missing. Do you know anything about that? So we spun up the PyHC Summer School environment for last summer's camp. It ran for 1 week, 80 simultaneous users on average. We let it stay up for a week or two afterwards so people could take their stuff down from GitHub. And then at the end, we nixed the environment. But the container is available for download if people wish to replicate the PyHC Summer School. More importantly, you can get PyHC Summer School's build and or you can get the PyHC tutorials that everyone ran from GitHub itself. So you could actually spin up a newer environment and grab the Summer School. So Rebecca's asking, yes, where? Can someone post the Summer School links if you have it available? If not, after I finish talking, I can post them into chat. But the Summer School tutorials and similar things are available. So she wants the link to the environment, the container. Yeah. So if she's asking about the container, then that's a link we have somewhere. Like I said, I'll post it after I wrap up because I only have like 2 minutes left based on when we started. But yeah, all this is to be shared. We're going to be putting everything publicly on GitHub when we go for release. And right now, again, you can be up and running with the stuff that we've provided today. So it's there, it works, it's getting better. Future progress, again, 300 terabytes of SDO data are public. See the web stuff is being moved over, in the process of being moved over. There's selected data sets of other sorts that are coming. There'll be contributed data sets from various things. I have a NASA make ML ready data set from Soho plus Stereo that we'll be putting on up. And so there's a lot of stuff going on in the future. And what we really want to improve is ease of use, but also tools that now go more into like kind of the stuff Ashley was talking about and what some of the other talks on. How do you share data with other people? How do you share results? Getting into the shareability types of things. So to close out, if you have questions, you can always reach out to me. If you want access to Helio Cloud itself, go to heliocloud.org to see a very minimal business card type page. And then you can contact Brian Thomas to ask for an account. What is Helio Cloud source of funding? HDRL is the one that is funding. So NASA Heliophysics is funding the Helio Cloud development and the HDRL build that is providing accounts to people. And that is a relatively stable pool of money. And again, we want to aggressively collaborate. We can't do Helio Cloud without PyHC, and so PyHC will always be part of Helio Cloud's DNA. And we see a lot of you PyHCers as our primary users because you're power users. So we'd love to continue working with you all. And I'm happy to answer questions in chat or similar. Thank you.
Any questions in the room for Sandy? Don't see any more online questions.
Well, if I answer them in line, I will hunt up that container and other links and post them in the chat. Thank you.
Yes, thank you, Sandy, for answering questions during the talk. Always appreciate that. You mentioned I should talk to Brian if I want to know the current state of the importable packages, right? In Helio Cloud?
Yep.
Okay, I can do that. And are you guys still using Conda? I assume you haven't brought in any pip packages.
So Brian and Jeff, and I think his new hire are the ones working on the container. So I am not entirely certain on the container stuff.
All good. I will bark up that tree with someone else. Thank you. Yep.
So one thing I'd be interested to hear about from people in the room or online is, what do you see as barriers for you or the scientists you work with to getting into the cloud? Or what attitudes do you see towards that? Do you see people looking forward to it? Do you see people dreading it? Do you see people just kind of ignoring it or not knowing about it? What do people, because there was a interest poll at a kind of a PyHC meeting last summer, and cloud stuff came out kind of low. So are people still thinking that, or, what do people think about moving to the cloud right now? Oh, eventually, but not now, just so.
I think a lot of people still think the cloud is different. That something I hear a lot is, will our code run on the cloud? And their code is a Python script that reads the CDF file. And I think at some point people don't quite realize that an EC2 virtual machine is just a Linux server. And if you can move around in a Linux server, you can move around in an EC2 instance. I think there's a lot of cloudiness about that still.
I love the pun there.
Yeah, we also eat it there. So I can maybe speak a little bit to the zeitgeist or whatever the term is. I would be kind of reluctant to tying my science work to a proprietary commercial platform like AWS or whatever. I think we talked a little bit after hours about, so I'm wondering about if there's some more open source proprietary or provider for these cloud services that could be substituted if AWS goes down, or if Amazon does something too onerous or something like that. I did a little good Google search earlier, and I turned up Apache Cloud Stack. Is that one of the options?
So there's two layers. The first is we put the file registry, so it shouldn't matter where the data is. You should be able to analyze, on different clouds with different data sources. And there's actually going to be an IDEA Cloud Working Group meeting in July, where we're going to be talking about how do we do cross cloud sharing so we're not tied to a platform, because ESA doesn't use AWS, but everyone can use Dask. Dask is a way for bursting into multiple CPUs that is not tied into a specific cloud provider. So I
Right.
think we really have to keep hammering on what you say of go with open source implementations and standards and APIs rather than proprietary platforms.
Right. I mean, Amazon is fairly solid as a going business concern, but all of those currents will shift in over decades. Another thing for me personally, I have family up in rural Montana, and it would be nice to be able to continue to do some of my science work when I'm visiting them and the internet is completely unreliable unless I want to tether to my phone or something. And even that's not ideal. So the idea of being able to do a lot of my work on a good performance laptop is pretty appealing. And a lot of my workload is not super like storage or compute intensive. So I feel like there's a pretty significant place for local compute resources there as well.
If you're not storage and compute intensive, then you will access the cloud once to copy the small subset of data you need, and then yeah, you're good to go offline. That's a very traditional thing. What we're trying to emphasize with cloud is the kinds of problems that couldn't be tackled on a laptop before, to open up new science and bigger things. Because cloud high performance computing never makes anything go faster. It just lets us scale the project size larger.
Yeah. I was going to say, if your workload is not very parallelized, then the cloud compute resources are not actually any better than a good laptop or workstation, because it's still going to be like an Intel computer and a few Intel cores running at 2 to 4 gigahertz or something like that.
And most people don't use all the cores on their computers already. So a lot of, for smaller projects, standard projects, a lot of people are underutilizing their laptop. But again, we're going for projects that you can scale up.
Yeah, this is Sasha Drozdov. I can tell from the personal experience why cloud is a bit of a scary option as being a researcher. It's basically a question of money, because clouds can be very expensive. And I'm only familiar with clouds because I work with the company that has a CTR grant. And there was some unpredictable charges occurred, because the instance was not shut down, and it was keep running and no one noticed that. And as a researcher, and I have only grants from NASA, that's essentially what cutting out of my salary, even if I repurpose the funds, or if I trying to allocate it before when I'm writing the grant, I say, oh, this is how much I would spend. I actually don't know if this will be enough. So because it's because cost can not predictable, it's difficult to think ahead about how can you use the cloud in order to make things work, because you never know how much time you would need. So I would rather use resources that I have, maybe a desktop, not necessarily a laptop, to run the computers, or the servers that I have at the university that I can use, than the cloud. But what you show, it's actually very impressive. I was very impressed about how this can be scaled up.
Yeah, that scaling is the point, right? So now you know that you can scan through all those images that quickly. There's other science questions you may think of now that you know that's not hard or prohibitive, because you never scan through one time, right? You're tweaking that algorithm. You're, now I found this. Now I want to try it again. So if it takes 27 days, you're really only going to do it once or twice, right? But if it takes 30 minutes, it now becomes part of that inner loop of try, evaluate, rethink, and that it expands the kinds of problems you might even try to tackle. I've seen papers on, we found these things in MMS data and they looked at 1.5 months because that's what fit on their hard drive. right? And the study of the entire mission, it's like, oh, well, I can't do that, right? So, but you can. And that's the kind of thinking that this project is trying to clarify, that no, you can think big. You can think the entire thing. Oh, I wanted to compare MMS with Van Allen probes and pull in Themis, and okay, once we get all, and the target is to get all of CETA cached in the cloud for the same kind of scanning, right? So then you could think about combining and scanning through everything. Do I see the same kind of magnetopause crossings for all of these missions, right? It's right. And so eventually institutions hopefully will start switching some of their institutional overhead support money to cloud. And then you're only going to pay for what you have. And so, yeah, it might run out before the end of the year once it gets popular. But, we spend so much per year on maintaining these clusters and these RAID arrays and so forth. And we also need to start putting 15, 20, 30K per year towards cloud resources as well. That way people, and then maybe we can start decreasing what we have on-prem.
I'm going to add in that I think in the future, people that are doing big data or large number of CPU compute heavy things, probably 5% of your NASA proposal will be for cloud costs. If you're going to use the cloud, that's kind of my very rough back of the envelope calculation.
Just jump in, Will.
Yeah, this is Will. So I just wanted to respond to your question, John, about what are the kind of perceived barriers to for people adopting cloud usage. I think one of them is, especially based on this demo that we saw, we're basically asking people to learn a bunch of new tools in order to utilize the cloud. So they have to sort of roughly understand what this registry is. They have to learn, how S3 works to some extent. But I think one of the selling points of Pangeo was, at least initially to the earth sciences community, was that they could use a lot of the same tools, basically all the same tools they were already using, things like that Ashley showed in his talk. But the only difference was that they were running on 5 terabytes of data instead of like the 1 gigabyte of data they had on their laptop, right? That was the selling point, is that you could basically move to the cloud with almost zero friction. And I think until we get to that point where we can use the tools that we're already used to using in the same way we're using them on our laptops or our group clusters or whatever, that it's going to be a hard sell. And I'm not saying that there's not a trivial amount of work to be done there to enable that, but I think that's one of the barriers, is asking people to learn a bunch of new kind of esoteric tools to do their science in a new environment.
I would argue sort of the PyHC approach. We need to be building better APIs and libraries to make that much more seamless. And I think Dask as a project is great, because Dask, I was able to, with no knowledge in about 12 lines of copying code, be able to throw something out to 50 VMs. Mm-hmm. And I think we need that level of, you only have to learn a little bit. You don't have to change your approach.
Yeah, I definitely agree that I think it's a feedback loop between like the infrastructure builders and the people who are building the kind of more user-facing software. That, because it's it's not like I'm using SunPy because that's the use case I know, but like we didn't build SunPy with kind of like cloud use cases in mind, right? And I doubt very many people kind of build their software that way. So there may be kind of a feedback loop, and I definitely agree that Dask makes this a really so much easier, because it provides these APIs that look like NumPy arrays or pandas tables that actually can spread that work out amongst some arbitrary number of workers, and then how you choose like the engine for distributing that work is kind of that's something that a user almost can transparently swap in and out, whether it's your laptop or whether the backend isn't there at all, which is even better. That like the examples that on the SumPy side that we've tried to target are like for if you have an ND cube, for example, that's, you know, a space time cube, it shouldn't matter whether that the data array that underlies that ND cube, whether it's a Dask array, you know, that's distributed across, you know, a compute cluster or a cloud or whatever that, you know, holds, you know, 2 days worth of data, or if it's just on your laptop and it's, you know, 30 minutes of data, that workflow should be exactly the same. And I think that's sort of the kind of vision that I want to push towards.
Okay, I think we should probably move on to Sean's presentation now, the demo, I should say. Thanks, Sandy.
Try to present from this laptop, but then do a demo from mine. So you can leave it plugged in.
Okay, cool.
Alrighty, so just one moment. I downloaded my presentation onto this laptop just earlier this morning, so hopefully I can access that quickly. Okay, from the beginning. Okay, how's that looking on Zoom? Are we looking at just my slides there? Huh?
It's not updating. I
Right.
see the room.
Yep, then let me make sure the screen is sharing, and it is not sharing. That would do it. Where the hell? All right. Let's see here.
It's not sharing with Zoom.
Yeah, I know. I've got this weird 2 monitor setup here in the room, and I'm trying to look
Okay.
at the screen behind me to find the screen share controls. There we go. I think sharing screen 2 is what I'm going to want to do, because that's where the slides should go full screen. So hopefully this isn't weird. All right, you're probably seeing, yep, just a Windows desktop. And then if I go present from the beginning, now hopefully we're
Yes, it shows up
slides. Woohoo. All right. Well, I will run through this a little bit quickly here. I had like an hour allocated. We'll see if I can do it in 45 minutes, get the schedule back on track. What we're talking about is submitting Python packages to PyHC. This probably the first half of this talk will be fairly boring / a refresher for people who know anything about packaging Python code and publishing it, but that's okay. We're going to be talking about what a Python package is very briefly, how to publish it to pip and conda, and that'll be, you know, the first, you know, more than half the talk actually. But then at the end, I'll talk about PyHC's development standards, and I'll give a little demo of what it actually looks like to submit a package and have it show up on the PyHC projects page. So if you've never seen what that looks like before, by the end of this talk, you will. Just briefly before I go through this, these slides are available in our Google Drive folder, and I've got links to the resources that I used here in case you want to look at it. I'm pulling from like the PyPA authority for how to package Python, along with this cool little PyPackages Jupyter book, which is more user-friendly. And I'm got links to like the project edition instructions over here. So in case you can't find it later, there they are. Anyway, so what is a Python package at a real high level? It's just what makes your code portable. No surprise there. It's what lets you, when you're pip installing something, the thing you're installing is a Python package. The basic structure of a package I'm showing here on the right. And again, sorry if this is like super elementary for some of you. But you basically got the main things you are going to have is some kind of config file for your repo, which contains all the metadata about what you're packaging up. You've got the actual package code, and this special underscore init.py file is actually what makes it importable. You can leave it blank, but it's got to be there, or else you're not going to be able to install it as a package. And the one thing I like to point out on this slide here is we're recommending putting stuff in a source directory here. Not every Python package does this. You can totally have a valid package and just have all of your Python code just spread out flat on the root directory of the repo. But it's good practice to stick everything in a source directory because it creates some separation and adds some sanity to like your runtime environment. One example that I talk about is like if you're running PyTest just from the root directory of your package, sometimes if your code's just right there in the same directory, you don't know if you're running against your local code or the packaged code. So what? Question is, does Python automatically know to look in the source directory? And yes, if you install it as a package, it'll find it just fine. Obviously, if you're running it locally, you're going to want to do a path into the source. Yes, it does manage the namespace correctly. What's up, Nick?
It might be necessary to specify that it's in src in like the pyproject.toml file. So
Cool. We got one more.
So is it better maybe to separate code in a submodule, like where you actually have the functional everything and configs, documentation, packaging is a separate repository? Is it like a common practice or?
No,
really?
I would actually recommend against doing that. At least in the context of PyHC packages, that'd be so non-standard. I don't think anybody's doing that.
I'm pretty sure the documentation in the repository is actually one of our standards.
Yeah.
No, in the same repository as the code is the standard.
Yeah. Cool. That's it. All right. So let's talk about what it looks like to publish a package. I'm going to cover pip and conda in this talk, but it turns out actually publishing things to PyAPI to make them pip installable, at least in the way that I show here, is sort of a prerequisite to getting it into conda. So pip first, then conda. So most of us have probably used pip at least once before. Depending who you ask, it either stands for the preferred installer program or pip installs packages. I've not actually found a definitive explanation for what that acronym is, but it probably means both or changed at some point. Just a few little tricks that I like to mention, just so you know there is some meat in this portion of the talk. In case all you've ever done is pip install packages that have already been published from other people, you can install them onto your own system like a package without ever publishing it anywhere. The syntax to do that I'm showing here, if my mouse shows up, and no, it does not show up. Well, pip install.e, if you run that in the root directory of a Python repo you've got, it could install it onto your computer just like a normal package, which will help you see what it's like for other people to use it. Or you can install it in an editable mode by giving it the -e flag. And that makes it so that you can have it running on your machine like a package, but then you can edit the source code and the changes already reflect right there, which is great for development.
I will still warn that most of the installer backends do have great big, yes, this is a hack, don't always expect it to work.
Yes. And actually on that note, there's a lot of hacking and hope it works with pip, generally speaking, because it does not do a very good job of resolving dependencies. One of the nice things about conda is if you already have a virtual environment and you try to install a package in there where the version conflicts, like it would make a dependency conflict, it'll complain at you. And pip historically has not done that, but in case for anybody who does not know, my bottom bullet point here is saying as of version 20.3, they're actually using a new resolver in pip. And it actually does complain about some things, like if you try to install a package that adds a dependency conflict. I think you still definitely can install it and you can totally still break your environment, but they've got a resolver that's checking for that a little bit better now. So if you haven't upgraded pip in like 10 years, maybe try it out. The other thing to know in this ecosystem here is what a wheel is. And that is, that's like a binary version of the code. With source code, you may need compilers to compile it, whereas wheels allow direct installation. We're looking at PyPI here, which is the website where you publish pip packages. And if you've ever actually paid too close of attention to a page, you'll see there's a source distribution and a built distribution version of that page. The source distribution there is the source code. And then the build distribution is the wheels. And if you happen to have an all Python package, you can have one universal wheel that will run on every single operating system. If you happen to include other languages or other non-Python-y things inside your code, it will be necessary to build wheels for multiple operating systems. So the text is probably too small to see, but for SunPy over here, they've got wheels for, looks like Linux, Max on an ARM chip, and Max on an x86 chip. So you got to keep that in mind. So anyway, that's kind of the basics here. Now, how do you actually get your code published on the PyPI? Well, the basic steps are you prepare the code for packaging, you use a package tool to make your package, you use a publishing tool to publish it, and then you would install it with pip. This little diagram right here shows that the config file is consumed by the packaging tool, which outputs a package, and the publishing tool sends it off. I'm going to be showing a couple different ways to do this. There's sort of an old paradigm and a new paradigm for doing this. The way that's been done historically for like most of Python's existence was using setup tools and Twine, but some more modern tooling like Flit has been introduced, and I'll show that off. And then I'll kind of dig into each four of these bullet points one at a time, starting now. So preparing your code for packaging, that basically just means having a good repo and having all the files that need to be there. So you need to have some kind of metadata file, which historically has been like a setup.py and or a setup.config file. But this pyproject.toml thing that I'll talk about has been the new preferred way to describe metadata. You need your handy init file for it to be installable. And you should have a license and a README, etc. Although not, actually, yeah, the license of the README will get packaged into code. Some things you put in the repo, like documentation, don't actually make it into the package, but you should still have it there to have a good repo anyway. These next couple slides show what a metadata file looks like. And this is a setup.py file on the left and then a setup.config on the right. They both basically have the same kind of information. Apologies for the small text, but it's like the basic stuff you would want to know about a Python package, like what's its name, the version, who made it, short and long descriptions, what requirements it has, things like that. And setup.py, you know, had popularity for a very long time, but there's been this sort of chicken and egg problem where it itself is an executable Python file. And you can't know what dependencies are needed to run it without actually trying to run it, which is why this is now sort of considered the old way of doing it. And in come the new way of doing it is this pyproject.toml file. You'll see it has all of the same things. It has like the package name, version, description, all of that stuff. But using this toml format, it can actually be read without being executed. And pip in particular can read these project files, which makes dealing with dependency management a little bit nicer. So this is as of PEP 5.17 and 5.18. I probably should have written down the dates when those were passed, but I did not. It's fairly recent. I'll just encourage people to look into this. What's up?
The dates of the PEP is one thing, but the actual support has been a bit of a slow rollout, and particularly corner cases and bugs and such. So you do want to be running a fairly recent tool chain to be sure of this, particularly if you run into weirdness.
That's a salient point. I think I actually say somewhere in my talk later in this that in some cases you actually can't use a PyProject.toml yet. Like I think if you're bringing in other languages into your repo, for example, you would have to use a setup.py file.
Yeah, although they do play well together.
That's good.
And if you have both, again, it depends on exactly which version of the tool, but the PyProject.toml on newer tools gets preferred for pulling the metadata. If anybody, this is John Niehoff for those online. If anybody wants to know this particular like tar pit, please feel free to talk to me. I'm in this salt mine right now.
Sorry to hear it. Some camaraderie in the room. Okay, so let's see here. So that's preparing your repo, which is basically just getting your files and metadata in order, and then packaging tools to package it up. We'll talk about setup tools first, which is, like I was saying, kind of the older, popular, and fully featured thing. And then I've got a newer example with Flit is what's in these slides. So basically just two commands you have to care about here. I've got them listed as the 2 bullet points up top. The first thing you're going to do is you're going to make sure that you have setup tools, wheel, and twine installed, because that's what you'll be using to package it. And then what I'm showing off here is a repo for a generic Python package. I named it so cleverly. After I've run Python setup.py sdist bdist _ wheel, inside this repo has been generated a build folder, a Python package .egg info folder, and then this dist folder that's highlighted here in the picture with a tarball and a wheel file. And those there are your packaging files, package files. So once you have those, you publish them. And really the only thing to say about publishing them at this stage with Twine is it's a good idea to publish it to the test PyPI before you publish it to the real thing. You can simply just specify the repository test PyPI when you're uploading those things in your dist folder, and that will stick it up in a place where you can go pip install it by specifying the index to the test. And that way you can, see what it's like for people to install your package, play with it, make sure everything looks like you expect it to. And once satisfactory, Twine upload dist /star. And boom, then it's publicly available for everyone to download. Pretty straightforward. Now with Flit, it's basically the same process, and it's actually a similar process for lots of other modern tools. If you want me to justify in great detail why I cover Flit instead of poetry or other things, I could give some thoughts, but nothing too deeply. So sorry about that. Anyway, the thing to notice here is that the commands are just simpler. Like Flit init is something you can use to create a PyProject.toml file from scratch. If you don't even have a metadata file in your repo, it'll like give you prompts in the terminal, like, what do you want to name it? What's the version? And blah, blah, blah. So it'll walk you through that to make your config file. And then Flit build is all you do to make the package, and Flit publish is all you do to publish it. Pretty cool. This is just pictures of what this looks like in the repo, and shout out to Ashley for putting together these slides and for taking these pictures. And the top there, you see circled in purple, Flit init, and then you see it going through and prompting with some questions like what's the module name, the author, etc. And then at the bottom, written PyProject.toml. And then we're catting it out there just so you can see what it looks like. And Flit build is this command kind of over here. And you can see it starts making things, and it built the wheel. Next slide, Flit publish. It starts to do it, and then it asks for like the PyPI login, and Ashley hid his password there. So there you go. Can't steal Ashley's login info. But once you've done that, it is in PyPI. And again, you're done. Don't think I need to say much more about publishing to PyPI for pip installs to work. I have this slide about some other tools that I'm going to skip. I have this slide about complexities in packaging that I think I'm mostly going to skip, other than just to say there is some thinking required when you're going through these steps, like how do you want to handle versioning? There's actually some debate or some merits between different versioning schemes, like semantic versioning versus calendar versioning, which, just to be extra clear, semantic versioning is the major minor patch thing, like number. And then calendar versioning actually puts like the year and the month in the version. Yep, there's pros and cons to both of those. You should also, when you're specifying dependencies for your package, try to specify the minimum number of dependencies. Like if you don't absolutely need something, or if you can support a wider range of versions, please try to do that, because it makes it easier for playing nicely in an environment, especially like the PyHC environment. Where are we going? Here we go. But that's all I'll say about that. And then I'll quickly talk about publishing the Conda Forge, and then I'll show you how to get your lovely Python package added to PyHC. So quick refresher on Conda is it's a data science packaging system. It's not actually just Python specific. It's most popular in Python, but it does support other languages as well. But basically the way it's working is it's got this thing called channels, and channels are places where you can have packages installed. This slide here is recommending checking out Mamba as a drop-in smaller replacement that's faster than using the Anaconda, which is sort of bloated sometimes. This slide here basically shows the steps from left to right of what that looks like. This first side here is just to get the metadata file. The options are you can either write it yourself. It's a meta.yaml file, or there's tools like this Grayskull thing, which are really simple. You can just go to the website, punch in your package name, optionally a version, and it'll just generate the recipe for you. It's like once you have this in PyPI, most of the work's already done for you, actually. So you'll either use a tool or write the meta.yaml file yourself, and then adding it to a Conda channel is all done through GitHub. In case you did not know that, fun fact, it's all GitHub PRs. So what you're going to do is you would go to this, like if you wanted to add it to Conda Forge, they have Conda Forge /staged recipes. And you would go there. And then once you open a PR, they've got like bots that go through and start checking everything for you. I've got some pictures of what that looks like. Here in the top, there's Grayskull. There's a simple thing. You're seeing enter project name and version, and you click generate, and it shows that. And this is, we're using the example of publishing virus client to Conda in here. So you're seeing the meta.yaml file that was output for that, and it scraped all that info from PyPI. Then again, we're looking at Ashley's work over here. So we're seeing Ashley's GitHub username going and opening this GitHub PR, and you're seeing the Conda Forge linter going through and linting your code and checking it for issues. This part is all automated. Had to update some things to actually get the bot to accept this PR, but once up, yes, things we had to fix, like Ashley had to add some requirements to the metadata file, also some stuff about docs. A minor fix was needed for the CDF-lib package. That's also one thing to keep in mind is you can't publish a package to Conda Forge without all of its other dependencies being available in Conda. So I think in this case, I don't think CDF-lib was fully Conda compatible, and I think that was something we had to fix to get this in there. But anyway, once the GitHub PR goes through nicely, you get generated this feedstock repo in GitHub. So we're looking at Conda Forge /virus client feedstock. And this is basically your conda files right there. So you merge the PR and the staged recipes. This repo gets created. It provides all the configuration to build the package. And what's nice is that new releases on PyPI trigger automatic PRs to this repo. There can be a delay sometimes of like a day, but for the most part, you can just update it in one spot and it gets updated in PyPI, it gets updated in Conda 2. You can take it one step further and you can actually use like GitHub Actions or some kind of CI build so that if you like make a release in GitHub, you could have that release automatically become a new version in PyPI, which automatically becomes a new version in Conda. So it just becomes this nice workflow of you develop in GitHub and make a release and everyone's happy. And yeah, this is, these pictures are just showing an automatic PR that was opened when Ashley bumped the version from 0.11.0 to 0.11.1. And woohoo, everything's published in CondaForge, and they give you these lovely badges you can proudly stick in your repo to show that you have the street cred of being published everywhere, and then you'll feel good about yourself. And I got a large chunk of notes that I won't go over. And this is the PyHC specific portion of the talk. And I'm not going to sit here and read off all the standards to you or preach to you about how you should be writing your code, but we have the standards document online. Here's all of the standards actually. Now that it's been seen, it's part of the meeting recording. You can go back later and look at it, or you can look at the slides. But basically, the thing that we're trying to motivate is interoperability among packages, open source collaboration, keeping our Python ecosystem as sane as possible, and just generally motivating good, clean code. Which good, clean code could be a whole thing that I think we're going to get into with Nick's talk after mine. So look forward to that. But in 3 bullet points, I can say just use good variable names, short functions that do one thing, and avoid code duplication, and you're already doing pretty great. I've got a link to Nick's slides, but I think we'll get a presentation from him, so you don't have to worry about that too much. And now I'm going to move into the part where I show you what it's like to actually add a package to PyHC. And I'll be switching laptops soon, so hopefully that doesn't cause too much chaos. But over here on the website, if you go to our Documents tab on the web page, you can find this adding a project to the PyHC project list document. And this really is the walkthrough of everything you need to do. But really, it just boils down to self-grading your project for how well you live up to the PyHC standards. And then you change like one file in the GitHub repo and you open a PR for it, and I approve it. Yep, this is the part where at the demo. So let's see. I am going to move over to my Mac. I think I'm going to stop the screen sharing here, and hopefully it's as seamless as just screen sharing from my Mac, and then we keep going. Alrighty. Let's see. I've got Zoom open. And I want to show this. Okay, are we seeing GitHub people on Zoom? Yes? Woohoo! All right. I don't want to move this laptop, but I also don't want to hold it. Let's do that. There we go. That'll work. So what I did here is I made just a cute little demo repo. This is my GitHub / my PyHC package. And if we see down here in the README, this is a GitHub repo for my awesome Python package that will transform heliophysics forever. It definitely belongs in PyHC. So what we would do if we were adding this now is we would go to the website, like I said, And we have the project edition instructions. This is going to point you to things like the project page. I'll go ahead and open that in a tab real quick, because this is like the ultimate place. Once you are a PyHC package, you appear in the projects page. That's like the big thing you get. We have these project review guidelines that I will also click. Maybe, maybe not. No, I won't. But we have a link to project review guidelines that actually go through the standards and give you kind of a checklist, not just like, you know, you could read the standards document and interpret it yourself, but we actually give you like some bolded breakdowns, like a kind of a checklist, like, is my software mature? And it'll say like, does it do this, this, and this, and that kind of stuff. And that'll help you grade your project. The main thing you do, and I'll show you this right now, is you go to the PyHC website repo. Looks like that. And inside this data thing here, there's a projects.yaml file. And you're going to just add an entry there, just like all the other entries. These bullets are everything you're going to include. From here down are just grading badges. From here, you're just going to be adding your project's name, a link to the website, which in most cases is just the GitHub repo, a short description of what it does. If you have a logo for your repo, you can add a link to the logo and we display it on the website. If you don't use a logo, we just give you a filler like PyHC logo. Documentation, you have to have documentation. So we give a special link for the documentation and the code base, which is usually the same as the website there. And we need at least one contact from people. And this keywords thing, I'll point out real quickly because we don't do a super great job of advertising this. There's a PyHC taxonomy. You know what, sure. I'll use the pop-up feature. We have this little YAML file in our website repo, which splits up keywords into, I think, 7 different categories. Yeah, I can make that bigger if I just actually click the link. Yep. There we go. So this is to help get a grip on like what all the functionality in PyHC packages are and what they do. When you are on the projects page, we have these keyword filters that let you, in theory, help you find what you're looking for. You could say, I really want something about the heliosphere, and I really want the input-output formats to work with CSV files. Stuff like that. That's why we ask you to add the keywords, or if you care about specific missions, I'll just do the first one, ACE, and boom. These are the repos that work with ACE data. So we encourage you to look through this and add keywords from them to your GitHub PR. If you think you have a keyword that should belong in the taxonomy but isn't there, we welcome those additions in your PR too. But now let's actually open a pull request, shall we? So again, we're going to be adding my PyHC package. And I want to go to here. So first things first is you make a fork of the website repo. So heliophysicspy/heliophysicspy.github.io is the repo for the PyHC website. Go to the top right here and click fork. And you create your fork. For some reason, my terminal decided to fire up just then. That was fun. Create the fork. It'll take a few seconds, and then GitHub automatically redirects you to the page of your fork. So now we're looking at the website, but under my personal GitHub repo. And you can see that it's forked from PyHC. And underscore data, projects.yaml. Here you're seeing entries for all of the projects that we have on the website. To speed this up, I've gone ahead and written an entry for this. I'm just going to copy and paste. So we're not going to do this from scratch. But I'm showing the name, the link to the code repo, a description, a link to the docs, which in this case is just the docs folder of GitHub. That can be okay, even though like read the docs or something is generally better. Contact Sean Polson, here's some keywords. And then with these grading badges, maybe one thing I didn't cover super clearly a minute ago is that you have like one of three options to paste in here. Either you're gonna do a good evaluation, in which case we've got a link to this little SVG image of the badge with comma good, or you're gonna have requires improvement, which is this one here, or partially met. That's kind of like a red, yellow, green, like stoplight grading system we have. And that's why you see, where did my links go? That's all these guys right here. So anyway, I've copied my little entry. So in my fork, I'm just going to edit this file and scroll down to the bottom and add it to the list. Bam. Notice that it's nice and in line with the rest of them, contains all the same entries as the rest of them. And then I'm going to commit this. GitHub recently changed their UI, and now the commit changes buttons all the way at the top. It used to be at the bottom. Commit the changes, and then now they're in your fork. And how you open a PR from one fork into the main repo is you've got this contribute button right here. First, you'll see that you're one commit ahead of the main branch on the real one. You'll hit contribute, open pull request. And I'll just do something like adds my PyHC package. Cool. So you would open a really good PR. And then once this is open, I get pinged. I get like an email sent to my work email letting me know, hey, there's a new pull request open. And I'll jump into the website repo on GitHub here. I'll click pull requests. I'll see, hey, look. And actually we've had 2 submissions for new PyHC packages since the spring meeting started. So these are actual like real life ones, but we're not going to take a peek at them. This here, I'll go in here, and what I will do as a reviewer is I'll take a look at what you've added here and how you've graded yourself. And I will go pop open your repo. I will read through your code. I will see if I agree or disagree with any of your grading evaluations. If anything needs to be done, we'll have a conversation about it in the comments. If nothing needs to be done, then I'll just say, great job, you killed it. And then I approve, but I'm not going to be able to approve my own PR here. So I'm just going to go over and merge it. Squash and merge. Add test package. I will revert this. So this will not remain on the live website for very long, but this is actually going to stick it on the live website here. So once that's merged, we have a little CI job. You can see it running right here on GitHub. That will rebuild the website and redeploy it. While that's running, first I'll just prove to you that if I go into data projects.yaml, scroll all the way down, we can see my entry for my new package live on the website. And just to show this for something to look at while it's building, when we go in here, we've got 3 separate things. It builds the artifact. It will alert us that the artifact has been built, and then it will redeploy the website. Normally this takes only a matter of like 15 seconds. So I bet if I refresh, this will be a green check mark. Yep, report the build status. That's done. Deploy. I bet that's done. If I refresh it, woohoo. So now I will go back over to the projects page. And in theory now, if I refresh it, which I can't do because Zoom tools are blocking my refresh buttons. So I'm just going to type it from scratch. Oh, I could have done Command R. Now if I search my, woohoo, look at that. There it is, my PyHC package, an awesome Python package that will transform heliophysics forever. Requires improvement on documentation, testing's partially met, everything else is good. So that's the entire process, start to finish. You do that and you have a PyHC package. And that is getting to the end of my time, and that's pretty much the end of my talk. So I think this is the part where I say thank you and open it for questions.
So I checked Conda and one of my packages dependencies is not there yet. What do I do?
Yep. What do you do? Hey, Ashley, are you still online? You went through this, didn't you? Do you remember what that actually looked like?
I'm here. Well, actually, no, it wasn't a problem for me. CDFlib had recently been added. I mean, what you do is you can try and get the dependencies also packaged on CondaForge. So you have to have them on CondaForge first before your project can be added. So try and push for that to happen. Maybe have a go at it yourself.
Would that, is that just like you would reach out to the maintainers of the package and just politely ask them to add it to CondaForge, or is there a better way?
Sure. I mean, you could just as a starting point open an issue on their repository, just saying, can we look into getting this on CondaForge? And go from there. You know.
You actually don't have to be the author, the original author of a package to add something to CondaForge. You can do that.
That's right. Yeah.
Like anyone can do that.
Yeah. So you can try and go through this process of adding the CondaForge package, and when you're doing that in the pull request on the CondaForge project, you can specify who would be maintainers. So, if you're looking to get your package on CondaForge, then you should probably have a go at getting the dependency on CondaForge. If no one's free to do that, you can just try to do that one first, and you can talk to the authors of that dependency and ask them about it, and then you can add them as a maintainer for the recipe as well, so that you're both maintainers.
Cool.
So this is actually the GeoPack package. So I suspect a sticking point might be, this is probably a wrapper around a Fortran library. So
I think you're right.
Yeah. So is that a big hassle, or?
I've never tried it, but in theory, Conda is actually more language agnostic than PyPI. Like, it doesn't have to just be Python code in there. So I would imagine that, yeah, you can totally make that work.
Yeah, you could have a go at it. Basically, that's what I would recommend. So I was trying to do the same thing with Apex Py, which also has Fortran. And it doesn't cost anything to just have a go, apart from your time. And you can. I mean, the situation with Apex Py, I opened the pull request on CondaForge to start trying to build the Conda package there, and the Linux builds appeared to work, but not the Windows and Mac ones.
Okay.
But yeah, it'll be some work. Yeah.
Gotcha. Julie, you had something?
Yeah. So if I submit a package and it's not yet good in one of the categories or any of the categories, hopefully that's not the case. Do we have any kind of timeline or rules for when we need to get it to good to really match our standards?
Yeah, that's a good question. We sort of had that discussion yesterday about, we have a lot of packages that haven't been graded at all. And we rehashed that out, so I won't rehash that out here. In general, no, you do not have to have a good rating across the board to be added to PyHC. that's sort of a my personal discretion thing. I sort of get to decide whether or not it's worth the state of your code being published and put under our name. So you're sort of at my mercy, but generally speaking, I'm not strict about this if you actually have a good use case in the community.
Makes sense. Before I give it to you, Nick, there was a couple questions in the chat. Will said there used to be a preview of the webpage on the PR. Does that not work anymore?
Good question. No, that does not. Actually, the entire CI build that we used to have for deploying to the website is totally not used anymore. So we transitioned over to GitHub Actions. I think it used to use like Circle CI or something, but when we moved away from that, yeah, some stuff like the preview went away.
Cool. There was another question, which I think I can actually answer. Are those labels, e.g. good, partially met, etc., tagged by ourselves? And that would be yes. You submit a PR and tag that yourself, and then Sean can tell you if he agrees with that rating.
Yep. Yeah, we've got a few hands in the room. I forgot the order of them at this point.
Yeah, so I think part of the discussion yesterday involved like grading of packages and or something like that, right?
Yeah.
I suppose there could be a scheme where it's like these are great core packages, they're essential and so on and so forth. You're fully encouraged to use those all the way down to there's something that somebody turned in, and not a judgment call, but you should use this only if it's necessary for your specific workflow or something like that.
Yep.
And maybe a degree of kind of community support behind a package should tie into that. Whereas some packages are just some specific person's pet project that's mostly just for something they need, versus this is a package that all the community is contributing to and has some ownership of.
Absolutely. And that, generally speaking, is the reasoning behind the split between having core packages and other packages on the website right now. And there's soon to be a third category of like ungraded, use at your own risk kind of stuff.
Who's next?
I'm seeing in the chat, Sunby has a similar procedure. Okay, cool. And they link to their package review. Check that out. More questions in the room?
Yeah, I guess as usual, the devil's in the details, right? And your simple example is all straightforward and easy to follow. And when you do it to something real, you always find something wrong. And so that going through this process myself, it took a long time, and I'm still not 100% through in this and actually having mine work, right? And so there's just issues, right, that come up. And so finding those has been a nightmare of Google searches, basically, to find examples. I mean, for example, the hardest part right now is figure how do you actually build C code into your package and include it, right? I haven't found examples online that show how to actually do it.
Yeah.
You know, and so some of those types of things make it challenging to do it in reality, right? So just so there are issues.
I think John's got an idea for you there.
No, I don't have ideas quite so much as shared pain. Yeah, so I think I expect to get the C straightened out without too much difficulty. I mean, ultimately you have to kind of stay in setup tools, but using the new front ends, and then you can just do arbitrary stuff. It's harder on Conda Forge, and I think it's gonna be really hard for the Fortran on Conda Forge, but it also sounds like we've got at least 3 packages that are gonna have to suffer this. I don't know if that applies to you at all, Darren. Or...
You're a dependency to us, so anything you don't get to work, we can't.
Yeah, that's true. So, I mean, I'm going to suffer through some of this, but it sounds like Apex Pi has the issue. Jim, it sounds like you're needing it for Geopack. So we may need to have some of us figure out a way that we can collaborate on bashing our Fortran using stuff into Conda Forge. And I don't know if that means we just, set up a separate Zoom later or something.
So this problem that you're figuring out now is going to be very useful to a lot of people to understand how to do. So as you figure it out, please take notes so that this could be a PyHC resource for others.
Absolutely. And the more notes we get on this kind of stuff, the more we figure it out, the easier it will be for me to kind of pick up some of this stuff when I get around to having more free time. I mean, in theory, part of my job description is like helping people get things published to Conda Forge and fix issues like this. In planning meetings and stuff like that, I don't always have a bunch of time for that, but especially now that I know that I don't have to be the maintainer of a package to submit it to Conda, I might get inspired to just open a whole bunch of GitHub PRs. Anyway, we're about 10 minutes over my allotted time, which isn't a big deal, but should be wrapping up fairly soon. So any last sets of questions here in the room or online? Going once, going twice. Well, in that case, I think it might be time for a break.
Okay, cool. Yeah, break time. Thanks again, Sean. So I actually had shifted our schedule a little bit to accommodate us running behind a little. So let's come back at 11:25 and take a full actual 15-minute break.
Cool. So I'll type in Zoom. Does anyone else want put their food on the lunch HAO way. So is that WAY? Yeah. Yep. Julie, it's 11:25 is when we're back. Yeah, I'm gonna do a, yep. And then let me. Cool. Were you gonna try to present from this laptop? Cool. Is your presentation in the presentations Google Drive?
It is. It should be near the top.
Oh, I see.
Wait, I mean near the
Murphy.
bottom. Hold on.
That's the wrong one.
There.
Download. Let's make sure it like looks sane on this.
It. Wait a second. Is it there?
Is this supposed to be a PDF?
Let me.
Well,
it doesn't look like.
For what it's worth, what I just presented was a PowerPoint export from Google Slides, and it worked fine on this laptop.
Yeah, I thought I put this. No.
Yeah, we're only sharing the other screen, so.
I can't quite get to the.
Yeah,
there. Probably. I guess I didn't.
Well, homework.
I only asked this.
Oh, Just had to refresh the list.
That'll do it.
So then if I do download, does that,
Yeah, when I download it, that goes to a downloads folder on this computer somewhere.
should we mute this for a moment?
Yeah.
Okay, we'll probably get started in a moment or two.
Yeah. It's like, let's do this together and make some maybe elements of it. You don't have to create the all. Hey, break time. Can't do it that way. I was gonna say break time is over, but
Yeah.
I can't speak into my laptop. Nope.
All right, everyone, break time is officially done. Don't worry, lunch is going to come soon. So let's start back up with some clean scientific software writing from Nick Murphy.
Yeah. So new share and screen two.
Yep.
Okay. And then somehow I maximize this, right?
Yes.
How do I maximize this more than maximizing this?
That's a good question. From the way you've got it now, I think there might be like just view in the file menu for Chrome, and it might be like hide the menu bar.
This is probably good. All right. So yeah, thanks for everything, I guess. Happy to talk about writing clean scientific software. So these are slides that I've compiled over the last several years when I was looking for a means of procrastination of doing other things. So I've compiled a lot, and yeah, from a lot of different resources too. So I want to start off with where I'm coming from this. So this is not coming from years of experience writing clean code. I wish. Rather, these suggestions come from years of experience writing messy code and then having to live with the consequences. Cool. And definitely these talks are better with cat emojis for anyone still having to finish their presentation. Right. So the main takeaway of this presentation is that code is communication. We write code primarily to communicate with other developers, other software, research software engineers. And only incidentally do we write code for usage on a computer. So I want to start off with mentioning a few things like, first, how do we choose good variable names? And this is something which is difficult sometimes, but it's worth taking a little bit of extra effort. So we want to choose variable names that reveal the intention and meaning of the variable. So sometimes if you have a comment that defines what a variable is, it's worth thinking about, can we change that definition to be the variable itself? It also helps to avoid ambiguity. So things like, is electron gyro frequency an angular frequency, or one of those regular frequencies, which I forget what it's called. So factor 2 pi there. Yes, hertz. And then volume, if we have a variable named volume, is it going to be in cubic centimeters or barn megaparsecs, which is about 1/3 of a teaspoon. It helps to be consistent also. We usually want one word for each concept and to use that one word every time. It also helps to have searchable and pronounceable names. If we have a whole bunch of variables that start off with int underscore, if you're starting to do like a search in a document, it's gonna have a lot of accidental hits. So making sure that the names are searchable, and definitely avoid variables that have like one character in their variable name, except for things like loops. And it's also really important to choose clarity over brevity. So there's kind of been a, shall we say, Fortranic thinking of limiting variable names to 8 characters. And that limit doesn't exist anymore. So it's better to choose longer names than to have unclear abbreviations. Yes, to repeat, really long names sometimes can make it hard to parse what the code is doing. So you do want to think about it. But the way I usually think about it is that we should measure the length of the variable name, not by the number of characters, but by the time needed to understand its meaning. So it's.
So Nick, that's really good, because I was about to jump on as well that if your variable name gets too long and your lines get too long, it's harder to absorb it. So there's this really interesting trade-off, and this is, I think, a really good way of expressing it.
Yeah, and it depends also if the code that you're writing is going to be used a lot more often than it's read, or read more often than it's used. And most of the code that we write is going to be read more often than we use. So erring on the side of a little bit more longer variable names does help. All right. It also helps to change numbers to named constants. So if we have an expression, velocity equals minus 9.81 times time, where does the minus 9.81 come from? And are we sure it's correct? And what if we go to a different planet? So it really helps to use named constants to clarify intent. So we can do things like gravity or velocity equals gravitational acceleration times time. And that makes it a lot less ambiguous what we're trying to do. And it's also really helpful to use quantities with units rather than plain numbers. And so if we have an expression, the same one, velocity equals minus 9.81 times time, again, what units does that number have? And so we can use a units package like astropy.units or pint to prevent hundreds of $1 million mistakes, like the Mars probe that crashed in the 90s because of the unit conversion error. So one example of that is, like I mentioned, astropy.units, which is something that a lot of packages in PyHC use. And so we can take a number and multiply it by units.meter and divide it by units.second squared. And that ends up being really helpful because it'll take care of all of the unit conversions for you. And it also acts as an additional check to make sure that you're doing what you intend to be doing. All right, so Sean alluded to this earlier. How do we write clean functions? And there are 3 things. Functions should be short, do exactly one thing, and have no side effects. So by short, often in my own code, I usually start thinking a function is long if it has more than 10 lines, but that varies. If it's longer than 50 lines, then it ends up being really hard to keep everything from that function in your head. And I ended up looking up references on how long functions or methods can be before they start, the length starts having an adverse effect. And the one paper that I found was about 24 lines. So keeping things shorter than 20 to 30 lines is usually pretty helpful, and shorter does tend to be better. All right, so complex control flow, and that means a whole bunch of if statements and things like that. So in this function, is electron, we have a couple of nested if statements. And if statements tend to, in general, make code a bit harder to read. It's also kind of an indication that maybe the code is doing, or maybe the function is doing more than one thing. So it's harder to understand, it's harder to modify, and we're more likely to get bugs if we have a whole bunch of if statements. So one way to protect against that is to use guard clauses. So if we have the same function, we can split up the previous nested if blocks into separate guard statements. So in this example, it's fairly straightforward anyway, but if we say if not is close charge to the fundamental electric charge, whoops, then we can return false, it's not an electron. And then after that, we don't have to worry about that condition anymore. So it ends up producing a lot more readable code to put guard clauses ahead, and when possible to not make them nested. And like along these lines, being able to take care of edge cases first does end up making the code after that a lot easier to follow. All right, so The next thing I want to talk about is high level versus low level code. So in high level code, that is code that describes the big picture and abstracts away the implementation details. Low level code, on the other hand, describes the implementation details and contains the concrete instructions for the computer. So an example for this, if you want to have a high level function that cooks something, then you can describe the goal of the recipe. So a high level instruction would be bake a cake. And a low level instruction would be add 1 barn megaparsec of baking powder to flour. So it really helps to avoid mixing high level code with low level code. And when we do end up mixing high level code with low level code, it makes it a lot harder to understand what the program is doing. So if you have different statements mixed together, like what are the important statements going to be? And it also makes it harder to change the implementation. So it's important to separate the high level big picture code from the low level implementation details. And I'll go through an example of how to do that. So if we're doing a numerical simulation, we can, very broadly speaking, say that we're doing 4 steps. We read in the inputs, we set the initial conditions, we perform the time advances, and then output the results. So each of these steps could be a high level function. So let's go into the first step. And to do the first step, there are a couple things we need to do. Open the input file, read in each individual parameter and store it, and then close the input file. And that could be another set of mid-level functions. And then we can even go deeper to get to low-level code. And to read in each parameter, we would need to read in a line of text, parse the text, and then store the variable. And again, each of these could be a single function. So this is the general idea of how to write code as a top-down narrative. And this is called the step-down rule in some books by Bob Martin, Clean Code and possibly Clean Architecture. So again, separate high-level code from low-level code. Another thing I want to talk about is one refactoring strategy to take big complicated functions and make them a lot more readable, to make them shorter and to have more separation of concerns. So in this function, we have 3 steps and we want to calibrate observations. We first want to subtract the bias, and that's 20 lines of code in this example. Then we want to remove the dark current, another 20 lines of code. And then we want to flag cosmic rays, and that could be another 20 lines of code. The first thing to note is that this function does more than one thing. And what if we want to do only one of these steps, or we want to do them in a different order? And even more important than that, how do we test the individual steps? So code that is hard to test often is a hint that we want to refactor it and improve the implementation. And so in this example, we have comments that are describing a particular section of code. And we can take those comments and turn them into their own function. Or in Python, we could create a class for this and then create methods for each of these different steps. And so we can create these 3 functions: subtract bias, remove dark current, and flag cosmic rays. And then we can call each of those steps and get images at different levels of calibration. And then, so by doing this, we ended up changing a 60-line function to just 4 lines. And looking at each of the different steps, like the subtract bias functions, remove dark current, flag cosmic rays, those functions, they're going to end up being a lot more simpler. So difficult to test code is more than a hint. It's a strong nudge in the right direction, is a comment. Yes, that is very true. All right. So now I want to talk about a quote from the book Design Patterns, and that is to program to an interface, not an implementation. And there's a lot that goes into this quote. So let's take an example that is from heliophysics. So we're writing a program, and suppose that it makes heavy use of atomic data. And we're starting off by using the Chianti database, but we want to try using AtomDB instead. If we have high-level code that repeatedly calls Chianti, then it's going to be a pain to switch to AtomDB. But if our high-level code calls functions that call Chianti, then we only need to make changes at these interface functions instead. We only need to make them call AtomDB or to access AtomDB data. And if we do that, then the high-level code can remain unchanged. And in this case, the functions that are calling the database are, they're essentially the interface. They are the interface functions. And this ends up meaning that we don't have to change all of the things at once. Like we can keep the high-level code the same and only change the low-level implementation details. And this helps a lot by having these interfaces. So I want to go next to a graphic, which I spent a lot of time on, I'll have you know. It's hard to make those scribbles pretty exact. And so we have messy, unstable code on the left and clean, stable code on the right. And we have a boundary in between. I spent a lot of time choosing the fonts too. And yes, it does help to have a boundary between stable and unstable code. So there's one idea that we want to have the clean, stable code depend on the boundary rather than depending directly on the messy, unstable code. So when we're thinking of high-level functionality, we don't want to have to worry about the details. We want to be able to ignore those as much as we can. So we want to put them behind a boundary, and that boundary should remain stable. Oh, yes, I got ahead of myself. All right, we also want to strive for high cohesion and low coupling. So cohesion is the degree to which the contents of a module belong together. So how related are different functions to each other? If the functions are related and they change at the same time, then it helps to put them in the same place. Coupling is the degree to which the contents of a module depend on other modules. So if we have one module that has a bunch of functions that are intermixed with a bunch of functions from a different module, they're highly coupled to each other. And coupling makes code harder to change and understand. So code elements that change together at the same time for the same reasons belong together. And this is something that came from Clean Architecture by Bob Martin. And so we want to separate code elements that do not change with each other from each other. So the next thing I want to talk about is pretty Python specific, and these are new slides as of like last night or possibly this morning. So hot off the press. So it really helps to use auto formatters, linters, and refactoring tools. So one auto formatter is Black. It's a little controversial. It's highly opinionated, and it is not very configurable. The reason why it's helpful is that it doesn't let you think about formatting details. It chooses that for you. But if you don't like the style, then maybe you don't want to use it. But there are other auto formatters out there. And it's a way to make the code easier to read visually, while at the same time letting you avoid having to think about it. So not having to think about things is one of my favorite things in the universe. So Black or other auto formatters, AutoPep8, other ones that I can't remember at the moment. The next one is a pretty new tool, and it's called Rough, which if you've heard of Flake8 or used Flake8 before, it's pretty similar, except that it's written in Rust, and therefore it's like 40 times faster than Flake8. So Rough has a whole bunch of optional rule sets, and they've implemented rule sets from like, I think about 20 or 30 Flake8 extensions at this point. And these are optional rule sets, so you do have to enable them later. And this, I was going to say something, but apparently I didn't finish that. So I'll move on. The next thing is, oh yes, that was it. Rough can make auto corrections. So Flake8 will tell you problems with your code, but it won't fix things for you. Rough will fix things. And in that sense, it ends up saving a lot of time, and it can save a lot of effort during code review also. And Rebecca has a thing to say.
Autocorrect on iPhone is famous. Does that, what is your experience with Rough's autocorrect screwing up your code or how actually helping it?
I don't remember one case where Rough messed up my code.
So I don't know about Rough. I know Black actually parses all of your code, stores the resulting parse tree, makes the changes, parses it again, and makes sure it parses the same. So it's actually double checking that there's no functional changes, purely formatting. Does Rough do that? Do you know offhand, or?
It probably does. They do very carefully make sure that it doesn't change the abstract syntax tree.
Yeah, so these things have, because of course we've all had that experience, right? And this is why people don't use auto formatters. So this modern set of auto formatters just nails that problem.
Yes. So the next one, Rebecca, your question is very important for this one. So a new tool is called Sorcery, and this is a refactoring engine for Python. And the way it works is that you sign up, and then it will submit a pull request to a particular branch of a repository. A little bit awkward to use, but I found it to suggest some like great refactorings. And it's also caught a few things where, like in a search statement, it was a search parentheses, and then a statement, and then a close parentheses. And it turned out that that test would always turn true because it was a tuple that had a thing in it. And so it was able to catch that. And this was like an earlier version of Sorcery. And it can also transform a lot of for loops and things like that. Sorcery is also nice because you can create custom rules. They have a pretty Pythonic way of representing patterns. And I've only just started to look into it, but they do have some example custom rules. And if you have particular style guidelines or patterns that keep coming up that need correction, you can create these custom rules. Sorcery sometimes removes comments. So if you have a for loop with like a nested for loop with comments inside of it, sometimes it will remove those comments. And in those cases, you don't want to just accept Sorcery results. You need to inspect them, in my experience so far. I wish they had a way to not suggest changes that remove comments, but overall Sorcery can offer some pretty excellent refactorings. That really hard to think of. But yeah, like I mentioned, it's awkward to use in continuous integration. But you can have sorcery extensions to like PyCharm and probably VS Code also. All right. Julie, how am I doing on time? Okay, cool. So I'll talk about some testing best practices. And from the suggestions that I had about writing functions, those are similar to tests. So the first thing is to keep tests small when you can. And it's usually preferred, it usually works better to avoid having multiple assertions per test. And the reason why is that if you have one assert statement at the beginning of a test and it fails, then the subsequent assert statements will not be run. And because of that, there might be some test failures that get masked that would help you figure out how to fix things. So it can hide some important information from you. But that's not a strict rule. Sometimes there are assert statements that are like really closely related, or an assert statement that only makes sense if the previous assert statement works. Tests are harder to maintain when there is complex logic. The tests are harder to maintain if there's complex logic in it. So tests that have conditional statements, if statements, are an anti-pattern. They, again, indicate that the test is going to be doing more than one thing. We also want to make sure to keep tests fast. And we want to run tests often. That's like incredibly important. But sometimes there are things that are unavoidably slow, in which case you can have an option. You can use a PyTest mark to decorate a function or decorate a test function and say that it is slow. And so you can run only the not slow tests at the time. Another thing is to keep tests independent of each other. Tests that are interdependent are a lot harder to change and a lot harder to debug. And if you try to parallelize your tests, there are some PyTest extensions that do that. PyTest xdist is one example. Then tests that are interdependent of each other, like the order that the tests are run, can affect the outcome of the tests. So as much as possible, we want to keep tests independent of each other. And another one is to keep tests deterministic. So if we have a test that fails intermittently, that's a lot harder to tell when we fix it. There's one issue, one test failure that pops up in Plasma Pi like once every, I don't know, maybe 1,000 times that we run our tests. And we have no idea how to fix that. So it's still an open issue. We think we got it sometimes, but it's not. But if we keep tests deterministic, then we can like make sure that we know that it works, that it's fixed or not. So how do you test for functions that have inherently non-deterministic outcomes like solvers? I think I didn't include the slide that talks about this. So if you have solvers, there are some properties that a solver might have. So it might be like fourth order accurate in space and second order accurate in time. And one possibility would be to test those convergence properties. Another one would be to have exact solutions, which sometimes you have. And in particular, having exact solutions that maybe exercise only some of the terms in the equation at once. So like have a test that's specific for gravity and like pressure gradients, have another one that's for a specific type of plasma wave, things like that. And yeah, so that it is pretty difficult to do that. It might be worth looking into Hypothesis, which is a package for property-based testing, which would take maybe a 3-hour tutorial to really get into. All right. Oh, and for making tests deterministic, specifying the random seed does help. All right. So another testing best practice is to avoid testing implementation details. It's more important to test the high-level behavior. If we test the specific implementation details, then it's going to make it harder to change that code. The trade-off is that it can be a little bit harder to debug, so it is something that you do have to balance. And anytime you run into a bug, that's a symptom that you have a missing test. So if you run into a bug, add a test for that bug, and that will help us fix that bug and prevent it from happening again. Also, bugs tend to happen in clusters. They tend to be near each other. So when you run into a bug, think about how that function is being tested and if there are other like edge cases that you might not be thinking of. Also, using a code coverage tool is pretty handy. So coverage.py is one example, and there's a GitHub integration with CodeCov that can produce some pretty helpful reports and each pull request. So code coverage tool, what that does is tells us whether or not a line of code was run during a test. And if a line of code was run, that means that at least one test function called it. But if, so there was some coverage, but it doesn't necessarily mean that it was tested well. So you can't just rely on code coverage. But if a code coverage tool says that a line of code is not being covered in a test, then you can have an idea of what tests that you need to add, or you can figure out that there's some missing code. Yes, okay. And if code is difficult to test, consider refactoring the code. If you write tests at about the same time as the code, that's a lot easier to do. And again, this goes back to writing short functions that do one thing with no side effects. Okay, and I have a few more slides, but I can stop anytime. Okay, cool. So one surprise to me is that comments, despite popular opinion in scientific software, are not inherently good. So as we change code, comments can become out of date if we update the code, but don't update the corresponding comment. And therefore, the comments can contain misleading information. And comments can also sometimes get displaced from the code that they're originally meant to describe. And one saying, which definitely warrants a screaming cat emoji, is that a comment is a lie waiting to happen. Yikes. So well-commented code does not mean well-written code. Big surprise to me. So there are some comments that we don't need, like commented out code, and that can quickly become irrelevant. And we can use version control to take care of that instead. Comments that define variables don't necessarily need to be there. We can encode the definitions in the variable names themselves. Redundant comments like I equals I plus 1, increment I, we can read the code and understand what's going on from that. So we don't need something which can be read from the code. And if we have a function, so again, this is like the extract function refactoring pattern that if we have a comment, we can create a function that does the thing in that comment and have the comment be the name of that function. Also, there is some peril in describing the implementation details in a comment. And the reason why is that the comment will then become obsolete if the implementation changes. All right, so it's better to communicate the implementation in the code itself rather than in comments. We can't always do that, but it's worth thinking about if we can. All right. So a couple of helpful common practices are to refactor code instead of explaining how it works, explaining the intent and interface. We want to amplify important points, things that we want our future selves and future contributors to remember. One thing that you can't do in code is to explain why a particular approach was not used. So you can warn future contributors about rabbit holes that might have dragons in them. Comments can also provide references. That also is usually helpful to include in a doc string for Python. And you can, if your code is going to be used by students especially, then you can explain some comments to them. And it's really important to update comments when updating code. So I will put up my summary slides and conclude with code is communication, write short functions that do one thing with no side effects, and run tests often. Woo, I'm done. All right. Okay. Oh, if you have your hand raised, feel free to ask the question.
Yeah, I had a question. Hopefully I'm not opening a rabbit hole potential depths. But in terms of testing, in terms of making tests reliable, making them quick, I wonder for tests for functions that download data, any sort of scientific data from the internet. I don't know if you can comment on how to make those functions reliable in case of like the server that hosts the data goes down, or I mean, the inevitable sometimes the data on the archive changes, and I'm not sure how to deal with that. And the other one in terms of like reproducibility aspect of it, for functions that say for a paper like that produce a plot, are there ways that you would recommend to like test those functions to make sure that subsequent runs of the code produce the same plot and not something completely different?
Oh, for the second question, I wonder if someone from SunPy could answer this, because I vaguely recall there being some strategy for testing figures.
Yeah, this is Will. I think I was probably going to say the exact same thing that you were going to say, Nick. So we, on the SunPy side, we run a lot of what we call figure tests. So there's a PyTest plugin called PyTest MPL or something like that. I can't remember exactly what it's called, but basically you make like a reference plot, so the plot you expect, and then that you have hashes of those like the PNGs of those plots, and then your test is to like rebuild that plot, and then it does a comparison between those two hashes, and if you can set some like tolerance, like how different are they allowed to be, basically, so that if there are like small fluctuations, then you could say, okay, well those are okay, but if it surpasses some threshold, then the test will fail. And so what we do is basically we store like a set of figure hashes, and then we run tests. And so if something changes, whether it's result or like some upstream matplotlib styling thing changes, then our tests break, and we have to like figure out why. Yeah.
That also work for interactive figures? Like Plotly?
No. Yeah, I mean, testing the interaction is a separate issue. Actually, I have an answer to Mike's first question as well. So with regards to, or maybe a partial answer, with regards to downloading tests that depend on files downloaded from a server and making sure you're like testing like the same file every time. So on the SunPy side, we have like a what we call a data manager, and basically what happens is that you can like annotate this. It works via a decorator, but you can imagine doing this some other way as well. That you decorate that function, but you say this is like the URL of the file that this test depends on, and then this is like the the hash of that file. And so what it does is that the first time it runs the test, if the file isn't there locally, it goes and downloads it. If it's there locally, it doesn't download it. So then you're not having that added latency if you don't need it. And then it also checks the hash of that file compared to the one it's downloaded versus the one you've said it should expect. And if that hash does not match, then the test fails because it tells you, okay, like something has changed on like upstream on the server that you're trying to pull the file from, and that you need to like address this basically. So that's one. You wouldn't have to necessarily use the SumPy functionality that we provide, but that's one sort of methodology you could employ for dealing with remote data products.
Oh, cool. Thanks. I'll check it out.
So I've got a couple other approaches to both of those actually. So for the plots, when you make a Matplotlib figure, you get a figure object back and you can do some inspection of that and see what it's like. So for instance, you don't necessarily care if Matplotlib changes its color bar. You just care that the values in there are the ones you wanted. Your goal is to test your code, not Matplotlib. And so you can do some inspection of that. If you combine that with the image hash, then you've got a really good idea of what's going on. Because if that passes and your image hash fails, it's probably Matplotlib changed. In terms of downloading stuff, a lot of this comes down to if it's hard to test, you probably want to refactor. And the more you can isolate stuff that interacts with the outside world, the less you have stuff that has messy tests. And so you might want to isolate that. And you can always use these testing structures and separate out the true unit tests that you run all the time that are really fast, and maybe have a small subset of tests that actually touch the outside world and do horrible things that you don't necessarily want to run as often, but make sure that those interfaces get checked too.
Yeah, I would definitely advocating for separating your online tests from your offline tests. In SumPy, because we are effectively like a data provider in a way, in that we provide an interface to a lot of other data sources for users, where we are forced to test like our ability to connect to these data providers. And those are the flakiest tests we have because things go like offline all the time. Parts of data providers go offline all the time. Yeah. So those tests are always failing. But we have a set of our offline tests that we can know that are not dependent on like some upstream data source changing. So yes, I would definitely advocate for like putting up a wall between those two things.
Yeah, and look for PyTest extensions. There are a lot of PyTest extensions out there that can be really helpful.
Yeah, and another idea of how you can deal with the data that you have to compare against. If you can containerize your test environment, you can actually include the data in the container and just update it in the container when needed. I actually have a question about the auto formatter. So like, because I don't know any of those like black, I think I come across Roof, but I didn't understand what it is and I skipped. But what about Prettier? Is it in the same scope or is it different?
Yes, it's in the same school. I think Prettier can work for different languages too, maybe?
Yeah, it's like the way how I know Prettier, it's like one of the most popular extension in the code, like VS Code. And for the code coverage, I don't know if anyone came across the problem, like in PySpeed as we have like basically the namespace, we designed the namespacing so it can be a little more convenient. And when I run the code coverage with the test, it actually goes through the almost entire project. And I don't know if you can isolate it to only look at the test and what the test what the test actually do instead of like going through the entire import of everything.
Oh, that's a good question. Might be worth talking offline about that.
All right, yeah, because it's a puzzle for me, yeah.
Someone else who has run into that before.
Okay, thanks, Nick. Okay, so technically we've started lunch. John has run out to go grab that for us when he comes back. A big thanks to John for organizing all that. But while we're waiting for him, I figured we could just quickly go through the unconference topic voting and figure out how we want to organize this. We have this room, and then I booked 2 other rooms as well for all of the, how long did I even give this? 1, 2, 2.5 or so hours of unconference talking time. So I'm going to be honest, the last time an unconference was organized, Alex was the lead. So I'm going to pull from your all's knowledge and ask how best you would like this to be done, since this is also for the people. Yeah, we can have Zoom open and do breakout rooms for each of those. So, ooh, can you record individual Zoom breakout rooms? Normally on conferences, I don't think are recorded. I was gonna give like a, I mean, there's a part in our Google Drive where you can put notes and like big takeaways and stuff from the sessions.
One thing I noticed is that there's at least 3 topics up there about running on the cloud or in S3 buckets. So can we combine things that are almost identical?
Oh yeah.
Okay.
That sounds great.
Have fun, Julie.
Also, the first topic about maintainer burnout and psychological safety and code review and abstract interfaces for instrument packages. Those are supposed to be 3 different topics. So, oops. But I think maybe for that last thing, abstract interfaces, we could save that for a hackathon topic tomorrow, since it might take a while to work on. That is pretty detailed.
All right.
That could be a more generalized topic, not just shared temperature responses, but we've been throwing ideas around over email and whatever about what about a PyHC coordinate converter or PyHC unit converter or whatnot, how that would be different from MastroPy and what we need and so on and so forth. I don't know.
Just to update on the breakout room thing, according to ChatGPT, the only room that will get recorded is the room that the host is in. So if the host bops around various rooms, we can get snippets of recordings for the breakout rooms, but we might just not record them. Yeah. ChatGPT connected to the browser plugin because I got access to that. GPT-4. But now I'm just bragging. Anyway.
Trying to think of the best way through this. Sure. I sent out an email. I'm forgetting when, but it was definitely before this meeting started, asking for people to submit unconference session ideas. So I literally ripped them from the Google form responses and put them in here. If you would like to advocate for them, we can take just a couple minutes, quickly run through them all. Nick, I'm pretty sure yours is the first one. Yeah, yeah, just super quick summary. Does not need to be long.
Okay. The first 3, maintainer burnout is really common in the maintainer community, and getting together and talking about how that's affecting us, how to resolve it, ways that we can change the culture or funding structure or whatever to do that. So that's the first one of the 3. Psychological safety and code review. So code review can be an incredibly helpful process, but it also can be soul crushing. And how to make sure that, especially for first-time contributors, we provide a positive experience. And the temperature response, save that for hackathon. Who's the Docker images?
We'll see a lot of these from me. All right, the Docker images thing. So scratch out Docker, just read virtual environment or container or whatever. We can have 5 different things. But the idea is that we want some sort of Python environment with all of our PyHC packages, at least core, installed and working happily together that could be referenceable. And want to talk about what that could look like. The next one's from me too. But that one, there's the S3 buckets and cloud environment stuff. That's all the same idea. Not all of it's from me, but that's, I really want to push for that because that's a current problem I have with the Open Science Experimental Helio Cloud. And SpacePy, Komodo, I really need you. So the Python for coders is not me. Is that you? That person might be online. You want the mic, Julie?
Infrastructure to scientific discovery impacts. Is that anyone here? Okay. We'll keep moving on. Discussion of how to discover, capture, and promote best practices.
So because I know we all love talking process. The reason I'm suggesting this is because our standards are 5 years old. And I think there's scope for us to share some best practices, some things that are maybe not quite standards, but that we want to encourage people to do, and having some sort of process for that. And so the analogy here is Python enhancement proposals, NumPy enhancement proposals, SunPy enhancement proposals, and just kind of how do we do business and how do we recommend doing things? Yeah. So some way of getting a very explicit community consensus around ideas.
Is anyone in here the one who talked about the PyHC summer school focus? Okay. It might have been, I think I yanked it from the end of a paragraph somewhere in any case. Create a better understanding of governance. Some of these can be fairly self-explanatory, I suppose. I think that one, was that you? That sounded like you. Discussion of what the vision is for PyHC packages as a whole. I feel like that's pretty self-explanatory. Did anyone in here put in the pros and cons of the various approaches on community? Yep.
I not only blow up the chat, I blow up this. Yeah, so packages that haven't formulated this, I think that kind of session and the notes that come from that session would be a useful resource. That's why I suggested it.
Did anyone put in this lunch session thing? Okay. I'd prefer for lunch to just be lunch personally, but. Okay. I'm kind of feeling like I'm getting the impression that most people would be interested in being involved in like most of these topics. Does it make sense to have breakout rooms, or should we just chill in this room and run through the topics? The breakout rooms are still there if we want them.
I like the chill in one massive room, given the numbers we have, because yeah, I'm interested in.
I don't think we're going to be able to do them justice.
Sorry, say that again, John. Yeah, not time to do 5 or 6 topics justice. Yeah. I don't think we could get through all of these for sure. Nick has a comment.
Yeah, I think last time we ended up having a grid of rooms and times And I think during lunch, we like talk through the process of like, where do we want to put this topic in this room and things like that. We'd probably need to do like an Excel spreadsheet or something. And maybe do that over lunch.
Can we see how many people on Zoom are interested in people? Oh, just because. Oh. Can we check how many people on Zoom are interested in being engaged with these? Because these are even less formal than what we've been doing to date. And obviously if remote folks want to be engaged, that's great. Let's arrange it. Otherwise we can shut down the Zoom and kind of huddle and simplify things.
Thanks, Angeline.
And obviously we'd report out and such and not like exclude people.
Yeah. Can we request like just like a yes or no from everyone?
Okay, yeah. In the chat, yes, yes or no. Or if you can thumbs up my comment, I'll take that too. Oh, yeah, it's not sharing the chat. That's a good question.
Does that make it into the Zoom recording or not?
Can someone on Zoom confirm for me?
Oh, looks like at least 2 people interested.
Okay. We will keep Zoom alive.
Well, that might be more reason then to not use breakout rooms if there's going to be any remote participation.
Mm-hmm. Okay, we can just stay in this room. That sounds better to me. Yeah, 3.
So I think it's very obvious that cloud enabling is.
Yeah.
I think it's very obvious that cloud enabling is something that there's interest in, since that was spread across 3 things and still came very close to the top. Otherwise, I don't know if we want to draw a line somewhere on the straw poll and then vote on the top 4 or top 5 or however many.
I would vote picking from 1, 2, 3, 4, 5, the top maybe 6.
I mean, I'd even say it looks like that the burnout is a runaway topic.
Just
so
a
that's
little.
pretty obvious. Cloud is
Can we
the other.
merge other topics? You know, you mentioned there's 3 cloud ones, so we can merge those.
Yeah. So and sorry, just running away here. Would it be worth discussing the idea of regular containerization in the cloud context? Those seem to have some rhyming. So cloud and containerization, maybe. I know it's different.
Different,
I
but
see it as
closely
different.
Like running on data stored in some cloud versus local is different than having a containerized or not containerized software environment on the cloud. Definitely closely related though.
Okay. I should not. Yeah, that's probably not. Okay.
Okay, so it looks like and containerization looks to be pretty much runaway the next thing. It's a long ways down to get to the Python for coders after the containerization.
Agreed.
Does containerization work for the bit Sean was talking of the hackathon to get the packages working together?
That's definitely.
Sorry, I could discuss that tomorrow.
That was my knee. I would say that they're related, and I would actually almost say that they're so related that I'm interested to hear thoughts on that in an unconference session, but I don't think we would need to spend too much time on it because I'm going to have a whole hackathon. We're going to be putting our heads together to try to actually get that working.
Yeah, I'm in a sort of let's cut down the list if things are covered. So if we could move that to your hackathon, that's fewer things to vote on or merge.
I second that, Sandy.
I think it's an agreement then.
But running on data in the cloud, those are those 3 topics that you combined? Sorry, say that again. You had 3 topics on running on data in S3 buckets or something similar.
Yeah, I remembered we'd had 3 topics there. to
Sorry, I
merge.
need more sleep. I can't see that part.
My bad. I can also probably make this less tiny.
Whoa, whoa, whoa.
What?
Yeah, a little too happy there.
I really want you to see.
I'm not blind. I'm just tired.
Let's go out one. Okay, I figured the unconference sessions each are an hour 15, so we could do 1 or 2 topics per that. So in theory, there's room for 1 or 2 more topics in the second hour. Yeah, different. Yeah.
But then again, Nick said that the first one that has a ton of
Yes.
votes is like 3 topics, period.
Yeah.
Yeah.
Maybe there's an interest in 1 or 2 specific parts of that.
Yeah, how much interest would there be in talking about psychological safety and code review?
Seems relevant.
Not overwhelming.
I'm all for the shared interface stuff. But maybe we need to split that up and get some votes separately in a more official way than just waving hands that we can't see Zoom.
Yeah.
Can you do a Zoom poll for just those 3, well, those 2 separated?
In theory, yes.
Those as 2 or 3, I can see that those 2 as complementary in some sense because I'm going to counter your proposal. Yeah, I'm going to counter your proposal and say, should we talk about human factors and soft skills and community arrangements and stuff and touch on burnout and psychological safety? Does that make sense?
It's a little broad, but maybe start off on burnout and then see where the conversation goes in the time that we have.
Yeah.
I like that.
Okay. That seems to be getting support.
Okay. Cool. So we have running on the cloud enabling maintainer burnout for the first foray of sessions. We have time for 1 or 2 more topics. Yeah.
I think that first one's gonna take more than just half that session.
You think, all right, I'll move. We can make it a whole.
I'm just saying. Yeah.
We could just make that one the thing and then shared. Woo.
Honestly, I think we've got 2 topics that will easily take up the time.
Okay. I mean, we can just focus on these.
And then if we turn out to have more time at the end, we can
Pull
talk
from
then, but
this.
I'd hate to waste a lot of time voting now and Discovery just don't have time to get to it.
Run through those to see how long they take and just bump them down as time runs out, right?
Sounds good.
Was there anything on there about coordinating on next proposals?
Oh yeah, that was not one that made it into here. We maybe that can be the third topic that we get to if we have time after these 2.
And we could also go back to the idea of breaking out again.
Yeah.
Yeah.
It's true. We can always do that if we get to the end of those 2 and want to.
But we can't do many topics all in the same room.
Yes.
And with
No. We do have 2 other rooms we can go to if we would like.
Lightning unconferencing, a new thing.
Okay, so maybe we start here and see how that goes. It's unconference, so by nature, it's not supposed to be wildly structured anyway.
Maybe think more during lunch while we're eating.
Yeah, let's all eat and think.
When should us online people come back then?
Good question.
As a delta, like 10 minutes from now or 15?
No, more time than that by far.
A half
Since
hour?
we do have the food here, we probably don't need the full hour 15 for lunch.
Yeah, no. Ah, this thing is being so difficult. Boop, 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 boop. Technically, we end at 1:25. Yeah, 45 minutes or so. 1:45? Oh, sorry, 1:25. Lunch break will be about 45 minutes.
Okay, thank you. I will come back online then.
Okay, so we'll be back at 1:25. Thanks for hanging in there with organizing this. My first time doing a conference here in person. So. All right, see y'all soon.
is doesn't mean what happens.
I try really hard to
Probably not.
I do work that I write.
Walking with wall.
That day. Not this day. You've got the mini map. Probably belongs to.
I use this excuse to. Okay.
Pleasantly presented. First step is to set the on-site ready. Friendly workspace technicians to help the participation. In room with your laptop preloaded with all presentations for your session. Speaker with the start time in the session chair with local activities announcements. Even the notes of the conduct of the session being recorded, attendees should submit questions. Then the chair will go right into the first presentation. All speakers and chairs will receive an email from Zoom with a link to your session. It is important to note that your custom link should not be shared. Please use this link to enter your session 15 minutes before it's scheduled to begin. When it's time to present, simply click the share screen button. If you have multiple screens or application products, Zoom will ask you which one you'd like to share. If you have any audio in your presentation, you'll get the share computer side options. This is what it will look like as you start to present. Only you will see these Zoom windows. Click the more button. There are options to hide the influence. Similarly, with your video window, during the Q&A portion, leave up the last slide of your presentation. And include your best contact info so attendees may reach out if they have further questions. At the end of your presentation, click the stop share button to stop share video. In the days before your presentation, test your internet speed. Make sure you have at least 2 megs up and 4 down. Device-wise, you can update the best for a phone or tablet. The headphones with a built-in microphone are best for audio quality. Inclusive of audio issues, please have the Zoom session easily accessible as possible. Before sharing your screen, presentation open, please monitor the program and windows to avoid unnecessary interruptions. You may use Zoom through a web browser or by downloading your app. If you do use the app, please test it first. Some operating systems will need to correct the app's provisions or it runs correctly. And we don't run into that during your presentation. Also, this can have 2 monitors you will not see your presentation. If you need them during the presentation, we recommend getting a computer. Simply printing it out. Hopefully, time by practicing your talk in advance, make sure you can put within your time limit. Leaving some time for questions. Session chairs will give verbal warnings to presenters who will keep the sessions on schedule. If there are additional attendee questions, those may be answered in Slack. And that's everything you need to know for a successful presentation. We look forward to seeing you at the show and mark your calendars now for the next one.
All right, that does it for the video. If anybody would like to raise their hand, stick their question in the chat, speak up. Any questions? Hi, thank you very much. James here on the college. Did I understand correctly that you said for in-person presentations, Zoom will be running already, and there's no need to do any share screen. That's only for remote. That is correct. Yes. And so when speakers, I'm going to be session chair. There's also a session chair training event that's separate from this.
Yeah, you're correct. We will have